Hi everyone, so let's see this topic now. Now we will implement muxes from muxes. Okay, so first we will implement lower level mux from a higher level mux. So usually this topic is not taught, even in the textbook you will not find it, but just sometimes interviewer can ask these kind of things just to puzzle you. So it is a very simple thing that you need to make 2 cross 1 mux from 4 cross 1. So this is given. The question is, it's not that you need to make 4 cross 1 from 2 cross 1. You need to make 2 cross 1 from 4 cross 1. So you have 4 cross 1 and you need to go to 2 cross 1. This is the question. Okay. So what is the scene in 2 cross 1? In 2 cross 1 there are number of inputs are 2. In 2 cross 1 number of inputs are 2. So you need only I0 and I1 input. And select line is only one, which is S, and this will be your output. So this select line I want, and I0 I1, and this will be Y, and this is your 2:1 mux. So this is what I want. So what I would do, I will keep this as ground, right? I will keep this as ground. Why do I keep it this ground? Because now S can take 0 value. If S takes 0 value, S1 is already 0. S takes 0 value. Look, S1 I have kept a ground. This is always 0. Now S can take 0 value. If S takes 0 value, what will be the output? I0 will be the output. So what will be your Y? Y will be S0. If S0 is not there and S1 is already 0. If S0 is not there, you will simply get I0. If S0 is not there, you will simply get I0 because S1 is already 0. Plus, if your S0 is there, you will get I1. Basically, if this is 1, then you will get I1. That's it. There is no use of I2 and I3. I2 and I3 I don't care here, and this will be the output. Y is equals to S0 bar I0 plus S0 into I1, and this is what you get in this one. So you have directly implemented 2 cross 1 from 4 cross 1. Very straightforward concept, right? And you need to make 2 cross 1 from 8 cross 1. What you will do? That's it. Now all these are 0. S2, S1, S0. These are 0, 0. Now just this will change the values. So it can take, this will be decimal value 0, this will be decimal value 1. That means it can take only I0 and I1. So what will be your Y? So if S0 is not there, then I0 will be there. And if S0 is there, then I1 will be there. That will be your Y. So using only one mux, you can create any lower level mux from higher level mux easily. Using only one mux. If you are having 8 cross 1, you can make 2 cross 1 and 4 cross 1 as well. 4 cross 1 also you will be easily able to make. How will you make 4 cross 1? You will keep S2 equals to 0. If you keep S2 equals to 0 and you keep varying S1 and S0. So very easy thing. Okay, sometimes like you might get puzzled. Okay, what they are asking. Now what is usually asked, this is that you need to implement higher level mux from a lower. So now let's start studying about implementing higher level mux from the lower level mux. Now this is an important topic. You need to implement higher level mux from a lower level mux. That means you are given 2 cross 1 mux, you need to make 4:1 mux. So you are having 2:1 mux and this is what you need to make. So for 4 cross 1 mux will have 4 input line, right? They will have 4 input line. 4 inputs line. 1, 2, 3, 4. They will have 4 input line. Now what do you have? You have 2 cross 1 mux only. So 2 cross 1 mux can take only 2 inputs line, right? So for 4 input line you require 2 cross 1 mux. This will have its own select line and this will also have its own select line. Now what do? They will generate 2 outputs. Each one will generate one output. So total 2 output will be there. Total 2 outputs are there. So 2 outputs are there, which will be fed to another 2 cross 1 mux, because 2 cross 1 mux can take 2 inputs. You wanted only one output, no? So finally this will give you one output. So this is how you implement 2 cross 1, 2 cross 1 and another 2 cross 1, right? So this will all will have their own select line. So this is this complete diagram. This complete diagram, if we say this complete diagram with the select lines, basically you can extend these select lines. नहीं होगी भाई. So if I extend these select lines, so with this complete diagram is your 4 cross 1 mux, right? This is your complete 4 cross 1 mux. So there are two select lines, S0 and S1. Which one will be S1? Which one will be S0? Okay, you tell me. Which one will be S1? Which one will be S0? This one will be S1 and these two ones will be S0. Why is that so? Look, I am considering this is your I0 and basically there are 4 inputs line, no? I0, I1, I2, I3. So if this is 0, this will be taken. And if this is 1, this will be taken. This is what I am considering. This is how I have written it. Okay. And basically this is your I0 dash and this is your I1 dash. So let's just say this is my input S0, S0, S1. This is my input. So if I put 0, 0, I should expect I0. Let's see if I am getting. If S1 is 0, then it will look at this. If S1 is 0, this will look at this. So this will look at the output of this mux. So if S0 is 0, what you will get here? I0. So at output, you will I0 only get. Basically S0 is 0. So this will give I0, this will give I2. But what S1 will look? S1 will look at I0 dash only. So output will be I0. If S1 is 1 and S0 is 0. Sorry. If S0 is 1 and S1 is 0. If S1 is 0, again it will look here only. And what is what is S0? S0 is 1. So if S0 is 1, I1 will come here. And that will be that will be your output. If S1 is 1, S0 is 0. If S1 is 1, it will look here. And S0 is 0. If S0 is 0, that means I2 will come here and that will be fed to the output. S0 is 0, that means I2 will come here and S1 is 1, so it will look here only. So I2 will be fed to the output. Are you getting this point? So here you are getting I2, here you are getting I1. In the last case, you will get I3 only. So if S1 is 1 and this is also 1, so I3 will come and will be fed to the output. So always keep this MSB bit of select line near to the output. MSB bit of select line near to the output. Bit of select line near to the output. Okay. Now, so how many muxes were required? 3 2 cross 1 muxes were required. Now there is another way of finding it. How will you do it? You need to find 4 cross 1 from 2 cross 1, right? So what you will do? 4 divided by 2. 4 divided by 2. What you are getting? 2. Now this 2 again can be divided by 2. 4 divided by 2. What do you get? 4 divided by 2. What do you get? 2 to the 4. So 2 you are getting. Now this 2 can again be divided by 2. What you will get? 1. 1 cannot be divided by 2. So forget about this one. Okay. So just as you are getting 1 in your answer, you need to stop there. So 1 you will not write. If you are getting 1 in your answer, you will stop there. Basically 2 by 2 is 1. So stop there. So 4 by 2 is 2 plus 2 by 2 is 1. That's it. 3 muxes are required. What did we do? We saw this number, we saw this number. 4 by 2. If we do 4 by 2, we get 2. So plus 2. Again divide by 2. What we get? 1. Again divide by 2. But just as we are getting 1, we are not going to look at this. This 1 we are going to ignore. So 2 plus 1, that is 3 mux required. So in that manner you can find. Let's see this question. For this question, how many mux will be required? What do you think? 8 by 2. What do you get 8 by 2? 8 by 2 is 4. So 4 is again divisible by 2. 4 by 2. 4 by 2, what that will be? 2. So 2 is again divisible by 2. Basically here I am not calculating anything, not writing down anything. Just writing 8 is divided by 2. What do we get? Plus 4 we get. 4 is divided by 2. What do we get? 2 we get. 2 is divided by 2. What do we get? 1. 1 we are not going to write. So here 4 plus 2 plus 1. Basically how many are there? 7. So what does it tell actually? In 8 cross 1 mux, there will be 8 inputs. So to take 8 inputs, you require 4 2 cross 1 mux. To take 8 inputs, you require 4 2 cross 1 mux. To take the 8 input. So 1, 0, 1, 2, 3, 4, 5, 6, 7. Basically 0 to 7. So I naught, I1, I2, I3, I4, I5, I6, I7. Okay, this bit we will see which bit will be what. So how many outputs are there? 4 outputs are there. Now to take 4 outputs, you need another 2 cross 1. Basically there are 4 outputs. No? There are 4 outputs. There are 4 outputs. 1, 2, 3, 4. So one can take only 2. So you need another 2. So this is what it shows. So I need another 2 now. So here I am getting another 2. Okay. So now these two will generate 2 outputs. Right. Now what do I need? To take these 2 outputs, I need another 2 cross 1 mux. So this is that one. So this is how 7 are required. Okay. Now these will have the select line, all will have the same select line, and these will also have the select lines, and these will also have the select line, and finally you are having output. Now which one will be what? There are 3 select lines, right? S0, S1, S2. S2 will always be near to the output. So this will be S2, this will be S1, and these will be S0. Why is that so? Let's look at this. Let's put a, sorry, it should be the other order, like S2 is the MSB, S1 and then S0. If I take 0, 0, 0, so if S2 is 0, it will look at this, right? If S1 is 0, it will look at this, and if S0 is 0, it will look at this. So I0 will travel here and go there. Let's take a random example. 1, 0, 1. What do you expect? 1, 0, 1. What do you expect? I5, right? I5 you will expect. In 8 cross 1, if 1, 0, 1 is there, what you will expect from here? I5, no? 1, 2, 4. Yeah, I5 you will expect. So let's see if we are getting it or not. So what is the value of S2? S2 is 1. Let's remove it off. S2 is 1. So if S2 is 1, it will look at this. What is the value of S1? S1 is 0. If S1 is 0, it will look at this. Here also something will come, but output of this is being fed here, but this is of no use. What we need to see, if S1 is 1, it will look at this output, and this output will be coming from this mux. So I am looking at only this mux only. So if S1 is 0, you will get this output. Now this output will come from this mux, so I will look at this mux only. Now S0 is 1. If S0 is 1, what you will get? This I5. So I5 will travel to the output. So our this value is correct. Let's take another example, 0, 1, 1. So if S0, S2 is 0, 0, 1, 1. If S2 is 0, it will look at this. Now I will look at this one, this mux only, because output I am not getting from this mux, I am getting from this mux. So that's why I will look at here only. Now if S1 is 1, if S1 is 1, this will come. And if S0 is 1, if S0 is 1, then I3 will come. So I3 will travel in that manner, and this is I3 only. So always this will be near to the output. Okay. How many muxes will be required? 2 cross 1 to make 16 cross 1. So 16 is there and 2 is there. 16 by 2. What you will get? 16 by 2, 8. 8 by 2. What you will get? 4. 4 by 2. What you will get? 2. 2 by 2. What you will get? 1. 1 we are not going to write. So this is 8 plus 4 plus 2 plus 1. What that would be? 15. So basically for 16 is to 1 mux. For 16 is to 1, 2:1 required were 15. For 8:1, 2:1 required were 7. You can see it, 7. And for 4:1, 2:1 required were 3, right? 3. So for 2 to the power n is to 1, how many 2:1 will be required? 2 to the power n minus 1. Let's take an example. You need to make, you can see it, no? 15, 7, 3, 2 to the power n minus 1. You need to make 256 cross 1 from 2 cross 1. From 2 cross 1. So how many numbers will be there? One thing you can do is that 256 divided by 2, what you will get? 128 divided by 2, 64. 64 can also be divisible by 2. 32. 32 again divisible by 2. 16 again divisible by 2. 8 again divisible by 2. 4 again divisible by 2. 2 divisible by 2, but you will get 1. So that's it. This is how you can calculate what this number will be. Can you tell me? It will be 255. Basically, one less of this number. That's it. One less of this number. So this number will be 255. Very easy, right? No issue about this. 2 to the power n minus 1. Just this number is there, minus 1. So this number was 8 minus 1. This number was 4 minus 1. So there will be 255 will be required. Okay. And if I directly need to write, this was example 1. If I take another example, 1224 is to 1 from 2 cross 1. How many would be required? 1023. Okay, so in that manner I will be able to write down. Now you need to implement 16:1 from 4:1. So how many those will be required? So the same thing you can do. 16 divided by 4. What you will get? 4. 4 is divided by 4. So 4 by 4 is 1. So next rest you are not going to do. So 16 divided by 4 is 4 plus 4 divided by 4 is 1. So answer is 5. You can see it. How? 16:1 will have 16 input line and 4:1 will have 4 inputs line. So it can take 4, it can also take 4, it can take 4 and it can also take 4. So 4, 4, 4, 4 they can take. So all can take 4, 4, 4, 4. Now how many outputs line were there? Will be there. Output lines will be there, will be 4 only. So only 4 outputs line will be there. And all these 4 can be taken by a 4 cross 1 mux. Because 4 cross 1 mux has the capability of taking 4 inputs line, and then this will be the output. So this is 4:1, 4:1. Now this is 4:1, it will have 2 select lines and they will also have 2 select lines, right? All select lines will be same only. Basically select lines are S3, S2, S1 and S0. So which one will go where? MSB ones, S3, S2 will go here, S3, S2, and LSB one, S1, S0 will be here, S1, S0 will be here. These two are the MSB ones. So MSB and near to MSB, S3, S2 will go here, and you can take an example. Okay, let's start taking example. Let's take a random example. 1010. What do you expect? I10. Where will be I10? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This we will be expecting. Let's check that out. So if S3, S2 is 10, S3, S2 is 10, S3, S2 is 10, 1 0. 1 0 means 2. So they will be 1 0 means I0, I1, I2. So they will be looking at this. And S1 S0 is 1 0. S1 S0 is 1 0. S1 S0 is 1 0. That means this is also equals to 2. So I0, I1, I2, they will be looking at this. So this will travel down to this one. So correct answer you are getting. Let's take another example. 0 1 1 1. So S3 S2 is 0 1. S3 S2 is 0 1. That means they will be looking at 1. Where is 1? This is 1. 1 1. If S1 S0 is 1 1, that means they will be looking at this. So this will be traveled. So this you will get as the output. At output you will get this. And what is this? I0, I1, I2, I3, I4, I5, I6, I7. So this is I7. Was the 7 only? Yes. So you are getting the correct answer. Okay, so MSB bit will always be near to the output, right? Just like this, I0, I1 in that manner, I2, I3, I4, I5, I6, I7, I8, I9, I10, I11, I12, I13, I14, I15. Okay, so in that manner you are writing the output. So this is your complete 16:1 mux. This was your 4:1, and this was your output. Okay, let's see the next one. Make 8:1 mux using minimum number of lower level mux. If I make 8:1 mux from 2:1 mux, so how many will be required? 7. So 7 will be required. This number is 7. But what they are saying, using minimum number of lower level mux. So I will try to make it from 4:1, right? 8:1 mux from 4:1 mux. So what I will do? 8 divided by 4. Now 8 is divisible by 4. 2 is coming. What does that mean? That basically there will be 8 divided by 4. 8 is divisible by 4. So what is left? 2 is left. So it will have 8 inputs. So one 4 cross 1 can take 4 inputs, and it will generate 2 outputs. It will generate 2 outputs, and these 2 outputs can be taken as an input by 2 cross 1 mux. This is 4 cross 1. This is 4 cross 1. So 2 4 cross 1 will be required. 2 4 cross 1 will be required to take 8 inputs. Now they will generate 2 outputs, which can be taken by 1 2 cross 1. So 8 divided by 4, what do you get? 2. You know that this can be divisible by 2. That means 2 4 cross 1 mux are required, plus 1 2 cross 1 mux is required. Now tell me one thing, if in the examination it is written that 8 cross 1 mux can be made by 2 4 cross 1 mux and 1 2 cross 1 mux. Is that statement correct? Yes, it is correct. Now if in the examination it is written like that 8:1 mux can be made from 3 4:1 mux. Is that statement correct? In the exam they are asking how many 4:1 4 cross 1 mux you require to make 8 cross 1 mux. So what you will do? 8 divided by 4. What we are getting? 2. Now you know this 2 can be implemented using 2 cross 1 mux, right? But certainly it can be implemented using 4 cross 1 mux as well. If some function is being implemented using 2 cross 1 mux, then certainly it can be implemented using 4 cross 1 mux as well. No, like there are two outputs line are there. So I will keep these as it is. I will keep this as grounded, and I will use only these two. This thing I told you here, no? So that's why I told this thing here. Now you are getting the point that you can make 2 cross 1 from 4 cross 1 any day. So if this here you can get your work done using 2 cross 1 mux only, then certainly 4 cross 1 mux will do the job. So this statement is also correct, right? Because 1 2 cross 1 mux can certainly be made from 4 cross 1 mux. So this statement is also correct. They were asking minimum number of lower level mux. So two possible answers are there. 2 4 cross 1 and 1 2 cross 1 mux. or 3 4 cross 1 mux. So here also you are using 3 mux only, 2 plus 1, and here you are using 3 mux only. So 2 possible answer would be there. Okay, I hope you must have understood it. So like this is the best case, but sometimes in the question paper this can also be written, that first you will do 8 by 4, then you will get to know that there are 2 lines. So using 4 cross 1 mux also I can make, using 8 cross 1 mux also I can make, using 60:1 mux also I can make it, right? Make 13:1 mux from 8:1 and 4:1 mux such that the MSB bit of select line should go to 8:1 mux. MSB bit of select line should go to 8:1 mux. What do you think? How we should start? Look, if I start like this, 32 by 8, that means first I am making 8, first I am making 8 cross 1 mux. Those will required will be 4, because 8 here, 8 here, 8 here, 8 here, total 32 inputs. So total 32 inputs it can take. So this is what I am doing. Then what I will be left with? 4 outputs, and these 4 outputs can go to 1 4:1 mux, 1 4:1 mux. So MSB bit will be here, and it will be fed to the 4 cross 1 mux. MSB bit is here and it will be fed to the 4 cross 1 mux. But what do you want? That MSB bit should be fed to the 8 cross 1 mux. So this design you do not want. So what you want? Initially there should be 4 cross 1 mux should be there. So you will require 8. You will require 8 of such kind, right? If there are 8 like this, so this will take 4, 4, 4, 4, 4 into 8, 32 input will be taken, and all will generate outputs. So how many outputs will be generated? Since they are 8, so 8 outputs will be generated. So 8 outputs will be generated. Now it can be taken by 8 cross 1 mux. Here you can see 32 by 4. What you will get? 8. 8 is simply divisible by 8 only. You can make it from 4 4 as well. Like 4 you use here, 4 you use here. This is also you can do. But final stage I want 8 cross 1 mux only. So final stage I want 8 cross 1 mux only. So basically there are 8 4 cross 1 mux. So what I can write? 8 4 cross 1 mux and 1 8 cross 1 mux. And let's write down the final design in some good manner. 1 I will make, 2 I will make, and directly 8th I will show. And then 8 input lines are there. So this is 4 cross 1 only. So total 8 are there. And this is your 8:1. So only 1 is there. Now all will be fed to the input here. So 8 input lines will be there. Right? This will be I0, I1, and finally it will be I7. Now these will have 3 select lines, and these will have 2 select lines. Now what all select lines will be there? S5, S4, S3, S2, and S1. So these 3, maximum 1 will be fed to this S5, S4, S3. And what about these 2? S2, S1. Shall we take any random example? Yes, we can take any random example. 1, 0, 1, 1, 0. So what that would be? 1, 2, 4, 8, 16. So you will be expecting 16 plus 4, 22. At the output you will be expecting 22. Okay. So what is written? 101. 101 means this is your 101. 101 means I5. So it will be looking at I5. 5. From here it will be looking at 5. Okay, like it will be very tough to show here because another 1 4 cross 1 mux I will have to show here, right? And then this is your 10. 10 means it will be looking at 2. So this bit will be coming. In 5th block, 3rd bit will be coming. 5th block, 3rd bit. So 4 here, 4 here. In 5th block, 3rd bit. So that means 23rd bit is coming. And what is 23rd bit? I22 only. And that is correct. If you are able to understand it, if you are able to visualize it, I am interested in I5. So that means I am interested in fifth block of 4 cross 1. Fifth block, third bit, because here it is 1 0. 1 0 means 2. So 0 1 2. So fifth block, third bit. Fifth block, third bit. What that would be? 22 only, right? Because each are having 4 4 input. So it will end at 3, then 7, then 11, and then 15, and then next will end at 19, and next will end at 23. So 23 is the last bit. I3 it is. So I want I2. That means I want 22. So 22 will be fed. And this design is absolutely correct. No issue about that. Okay. So in that manner you can make your design. Yeah. So one more question is there. Yeah. This is a question, you should try it on your own. Cost of a 2 to the power n cross 1 mux is 3 to the power n rupees. Basically 2 cross 1 mux will cost you 3 rupees. This question I made on my own only, not copied from anywhere. And 4 cross 1, which is 4 cross 1 mux, will take you 3 square rupees. That means it would be of rupees 9. 4 cross 1 mux will be of rupees 9. This will clear a lot of concept of yours. 8:1 will take how much rupees? 3 cube, that is 27 rupees. 16:1 mux will take how much rupees? 3 to the power 4, that is 81 rupees. And let's take the final one, that is 32 cross 1, 2 to the power 5. How much it will take? 243 rupees. Okay. Let's start. You need to design the mux such that the cost of your design is minimum. Let's start with the first one. You need to make 32 cross 1 using 8 and 4. 32 cross 1 using 8 and 4. So this 4 cross 1 is costing you 9 and 8 cross 1 is costing you 27. So you would want to use 8 cross 1 mux minimum. So let's try doing it. If I start from 8, so 8 4 is 32, 4, right? So you would need 4 here and 1 here. These 4 are 8:1 and this one is 4:1. So this is not a good idea, because 4 into 27, this will be 108 rupees. This is costing you 108 rupees, and this will cost you 9 rupees, right? So 108 plus 9, total 117 rupees it will cost you. Doesn't seem like a good idea. If I go by, first I go by 4 and then by 8. So first 32 by 4 is 8. So this is costing us 8, 4 cross 1 and 1 8:1. Okay. So 8 into 9, 72, and this has the cost of 27. 72 plus 27, this is costing you 99 rupees. So this would be a better design, right? But this is not the best design. We have other options as well. This was option A. Let's check for option B. So this is not a good design. It is costing me 170 rupees. This is costing me 99 rupees. So this could be one of my possible design, but let's check these. Use only 2 cross 1 mux. So 32:1 from 2 cross 1. How much it will take? How much it will take? 31, right? You know it, 31 it will take. Say yes or no? 32:1 from 2:1. 31 it will take. So 31, and each is costing you 3 rupees. So 31 into 3, 93 rupees. So certainly you are getting lesser than this. So this option is cut. Option A is gone, because this is the minimum. So till now this is minimum. Okay. These options are there: 117, 99 and 93. So till now this is minimum. So this option is gone. This option can never be correct. It is not minimum. What if we get even lesser than 93. Let's check that. Option C. 4:1 and 2:1. So 32:1 is there. We have option 4:1 and 2:1. If I do 32 by 4, 4 is 32. Then again I do by 4 only. So 4 2 8, and then I do this. So 8 plus 2, 10. This I have done by 4, this I have done by 4, this I have done by 2. 32 by 4, 8 you get, 8 by 4 you get 2, 2 by 2. So 8:10, this is 4:1 plus 1:2:1. So 10 into 1 is taking you how much rupees? 9. 10 into 9 plus this will take how much rupees? 3 rupees. 10 into 9 plus 3 rupees. So this is also taking 93 rupees. One of the option is again matching, that this is also taking 93 rupees. But this can be done by other designs as well. What could be the other design? Let's assume that I start with 2 only. So what I will get? 16 here. Then let's just say I am just going blindly, like you can make it from 4 now. 4 plus 4 by 4. So 16 plus 5. 16 2:1. 16 2:1 plus 5 4:1. So 16 into 3, what that would be? 48 plus 5 4 into 1. 5 4 into 1. 45. So again this is also taking us 93 rupees. So you can try all other combination as well. I have tried everything in rough notebook. So in all the combination you will get 93 rupees as well. Or here also you are getting 93. Right? Let's check option D. 16:1 and 2:1. So option D. 32 from 16:1 and 2:1. So 32 by 16, what you will get? 2, and 2 is divisible by 2. So how much you require? 2 16:1. 2 16:1 plus 1 2:1. So 2 16:1. How much it will cost you? Very much high rupees. 16:1. 81 into 2. 81 into 2, that would be 162, and this will cost you 3 rupees. So total 165 rupees it will cost. So this is not also feasible. So option B and C are correct. So option B and C are correct. Okay, see the last one. Last one I hope you must have understood. 32:1 from 16:1 and 2:1. So 32 I am starting from 16. So 32 by 16. 32 by 16 plus 2 by 2. So 32 by 16 you will get 2. 2 divided by 2. So this can be implemented from 2:1, and this can be implemented from 16:1. So here you will require 2 and here you will require 1. So 2 16:1 you require and 1 2:1 you require. So best design are B and C. So that's it about this video. That's it about this concept as well. I hope you must have found it interesting, and you will be able to implement any mux from any other mux, right? It's not a tough task. It is a very easy task, very straightforward task, right? So let's meet you in the next lecture. Next lecture is going to be very important. There we will implement any random boolean function from the mux, any random boolean function from the mux. So how should we define select lines, and how should we define the inputs I0, I1, I2, I3, I4, I5, I6, I7? So that I am going to tell. So for there are certain patterns. So 2 kind of cases we will see. So that let's check that in our next lecture. Okay. Thank you very much.